Okay, I think we are live. So welcome to my solo talk. I am giving my own talk, all by my lonesome, and it's mainly because I gave this talk at React NYC and the video got lost. So before this talk becomes out of date and when I forget everything that I talked about, I just wanted to record it for my future self and anyone who might be interested, which is probably just my mom. Hi, Mom. So let's talk about React Suspense. What is it? What it's about? First, I have to start with a disclaimer. I am not a React expert. I don't even play one on TV. And this is very much an evolving field, so don't do this. Don't use any of this in production. You may also want to notice the cute little octopus here, and that's an indication of a good slide. So we'll come back to that. And I want to start off with this talk with talking about what React does for us, right? Let's just kind of take a step back. What does React let us do without thinking? And the assertion here is that technology has a lot to do with things that abstractions that are not leaky, and it advances by extending a number of important operations which we can't perform without thinking about them. So if you ask yourself, why you like React at all, or any other framework as compared to vanilla JavaScript, there's a lot of reasons, first of all, but a lot of it comes down to components and clear sort of separation and giving up some of your degrees of freedom in exchange for an easier expectation of where things belong and how things come together. And that's what a framework is all about. So for example, I have this app here. It's coded in vanilla.js. And it's kind of a mess. There's a lot of code here. There's event listeners and remove event listeners hidden within the add event listeners. And it's not really clear where state is and where actions are and where the render code is. So as compared to a code base in React, you can actually mark out fairly easily where the state lives, where the imperative code is, and where the declarative render code is. So that's really nice, and that's what React helps us do. So that's the kind of frame of mind I encourage for people to think about what React tries to do for the users of React, and by extension, what Async React and React Suspense try to do for users of React. So now let's talk about what async rendering is. This is where I like to show off Andrew Clark's demo, and I'm going to insert the nice little lag waiter I have. And this is a nice Chrome extension you can go get from Async Render Toolbox. So over here we have, you see, so this just renders at 60 frames per second, and you can see red lines whenever the thread is being blocked. Whenever we render anything blocking, it also blocks the rest of the thread, and that makes the screen lock up. Now, if we make it async, no matter how many times we render, the rest of the screen is not really affected by that, and that's really nice. The other thing about async rendering is sometimes, so this is hard-coded, the blue section is hard-coded to return or render faster than the green section, and you can see like a little jumpiness here with the blue rendering faster than the green. So what React Suspense makes it easy for you to do is to coordinate things so you only display the blue and the green, the blue when the green is already ready, so they appear together at the same time. So you always have consistent states. That's what is one way to put it. So that's what async rendering lets us do. We're not really going to talk about how it works under the hood, because frankly, I don't really know, and it probably deserves a better, more extended discussion than we can do here. Async rendering, as explained by Danny Abramov's talk, is a combination of two features coming to React: time slicing, where in the CPU-bound case, and suspense in the I/O-bound case. For more, just check out his JSConf Iceland video. The extended explanation that they have is that async rendering, React apps should adapt to users' devices and networks. devices being the CPU case and networks being the IO case, so that fast interactions feel instant. For example, not showing spinners when you're loading things, and slower interactions still feel responsive. So you're not waiting, you're not locking up the screen while you're waiting for data to load. So those are the two things that are going on. I do want to mention, because I have a lot of these questions a lot of time, async rendering is very different from async data fetching. We've always been able to fetch data asynchronously. What we're talking about here is rendering the next, I guess, screen, or you can think about it as next screen of the app in the background asynchronously. You can start and stop as your processing power lets you do that. So that is the new thing compared to async data fetching. It is related though, so that's what makes it confusing. A little brief history about async rendering. It's been talked about since almost 4 years ago. Here's a lot of the original React team, including Jordan Walk, talking about async rendering in August of 2014. And one user is saying NEET on this, and LOL 4 years later. It's finally about to be here. The next bit of history that's relevant is the rewrite of React Fiber, and that was that took a long while. The first real public talks about it started coming in at ReactConf 2017. That's Lynn Clark's cartoon intro to Fiber. And around about December 2017 is when Sebastian Markbage came up with an API for React Suspense, which was meant to be controversial, but turned out not really, because it was so well demoed and communicated. So for more information, please do check out the 2 demos done by Danny Bramov. And there's a third one done by Andrew Clark at Site Day, where he demos a little bit of the streaming server-side rendering feature that might be coming to React Suspense, that will be coming to React Suspense. So what's again, so for going from async rendering now focusing in on React Suspense, what is, in their words, in the Facebook team's words, it's a generic way for components to suspend rendering while they load async data. So that's very nice. In a little more less pithy, but it's sort of more concrete terms, it's a fundamentally new capability that lets you render a component tree in the background while components are fetching data, and display them only after the whole tree is ready. For slow connections, it gives you full control over where and when to show a placeholder, which by the way is not part of the official React Suspense API, but it's a higher level API that you write for yourself. And it doesn't destroy the previous view while this is happening. So this part is very important to have things be interactive and to recover gracefully from failures. Who made React Suspense? That's easy. These are the attributions for different people on the team. Not so important if you're just using it. And when can you have it? By end 2018. But you can always already try it out, especially in the new React 16.4 release. It's available in unstable versions of the API. I don't like it. I don't have time to use it. Do I have to use it? No, it is 100% opt-in. So if you don't want to use any of it, you don't have to. And I think a lot of people like that it's entirely opt-in. And now I'm going to render a cheat sheet for React Suspense, but I don't have that data. So what I'm going to do is I'm going to suspend my own presentation. So you can see here the octopus has turned into a poop emoji because I just don't have my cheat sheet. So I need to halt this and go fetch my data. So this is where I switch to the other presentation. And now let's talk about the little bits and pieces of the React Suspense component that the community and the React team has figured out so far. This is very much still a work in progress. But here you notice we've suspended our thread, and we're going through a second presentation. So React Suspense cheat sheet, we're going to talk about 3 main sort of dimensions of it. They all overlap. I think it bodes it helps the conversation along if you're very clear about which aspect of React Suspense you're talking about, and people jump back and forth between each of these, and it can get quite confusing if you're not very clear which side you're on. So that's why I wanted to motivate this talk with the cheat sheet. So the new primitives that we're getting, React.timeout and React.async mode. The async mode is where you sort of wrap the tree of React where you want to opt in. Most of the time, you can just put your entire app in async mode, and in future that will be the default mode which React operates in. React.timeout currently does two jobs and maybe split into two separate components: a placeholder component and a timeout component. And you can see the source code in here if you click. You can obviously see the URL for the slides I have here. And that's it. And those are the only two primitives that are coming out from React that we know of. Everything else is done in user land. And there's a low-level API and a high-level API. The Facebook team has basically published a reference implementation of a cache, and the React Suspense feature only works with a cache, so they provided a sample cache. But this is expected to be written by, many versions of this will probably be written by people, including the Apollo and Relay teams. And the reference implementation is called Simple Cache Provider. It's about 300 lines of flow types source code, so it's not that intimidating if you go into it. And the two main things to look at are create resource and simple cache. But even here, it's so low level that you probably won't be dealing with this when you use React Suspense. You may want to use React.timeout as your own primitives, but you probably will be abstracted away because you want to pair it with a cache, and you probably want to have your own high-level API. So we'll talk about that. Here's the source code for the cache. It's it's got three methods: invalidate, read, and preload. And the types and natures are all here. So really not super complicated. But the main reason it's called React Suspense is in here, where in the read section, here's the definition of the read method, and here's the implementation of the read method. It goes through, and if it receives a suspender, which is a promise, it throws that promise, and it's caught by some kind of catcher function, like an error boundary or a React.timeout or whatever the eventual API is. Again, you can click here on any of the blue links to be sent directly to the source code. So with that low-level API done, people think that there will also be a high-level API wrapping a lot of these features in a nicer way, so that you don't run into a lot of the foot guns, as some people call it. So they essentially combine caches and primitives for you, so that you can just use them in your React code without having to worry about some of the things that people trip themselves up on. Here is this source code here is a reasonable implementation of what Dan Abramov was using in his import from future file. Here's a create fetcher command that basically connects simple cache providers create resource, which we talked about, and returns the result of the read. Here's a placeholder component that just basically puts some nice sugar around React.timeout. And then here's there is a new lower priority update API for React DOM. So React.component may want to have something called defer set state, which is demoed in the JSConf talk as well. And this is one way to do it, where you defer, you have lower priority versions of set state as compared to the standard priority versions of set state, which are more important and should probably correspond to user input or animation. And finally, here's the loading component, which Danny Momov adds on to signal things are loading in the background, and so on and so forth. There's a bunch more that I implemented in the future repo that's linked to there, and I will show you later on. Okay, so that's a lot of code. And I didn't really talk about the benefits or uses or goals that they're trying to achieve. But I think that was a good way to sort of establish the language that we are going to be using for the rest of this presentation and for talking about Suspense. So, for example, there is no such thing as a future fetcher thing. I actually have no idea how that even came about. Someone just talked about it, I guess, and then it became a thing. Create Fetcher is a high-level API, exists completely within userland, and you may not even end up using it anyway. You probably don't want to write your own cache, but Simple Cache Provider is there, and there will be others, so on and so forth. You get the idea. As long as you're very clear about what belongs, what is a primitive and what is not a primitive, you should be okay. So what are benefits? What's the difference between benefits and goals? Benefits and use cases address what can we do with it, and then goals are what are React's priorities in designing the thing. What are the big ideas that are being included in this? And I think the main thing is that React is getting a new job, which is solving the problem of data fetching. In video games, we talk about what you see here is a screenshot of Counter-Strike, but then there's this big line that's going through in the middle. And that's called tearing in game programming. And it's unacceptable for games because you're seeing an inconsistent state between the top and the bottom halves. So there's an argument here that spinners, like the ones that you see here, are a form of tearing, where you see something that's already rendered up top, and then you see something that hasn't been rendered, or might be out of date at the bottom. So that's a poor default. Like if that's what you're going for, that's good, but that's a poor default. And what if we flip that default to something better, which defaults to show consistent states? So over here we have a movie demo example. You know what? I'm gonna remotivate the discussion by actually going to this demo. Here's the repo I keep with all the async React stuff. And this is a very good clone by Rodrigo Pomber, I guess. And he's got a nice actual clone of the JSConf demo, which we're going to use. Okay, so here is a clone of the JSConf demo, I guess, and it's a master detail view. So if you click on any one of these, it's going to load all the requisite data. And once the data is finished, then it just shows the final screen, right? So master detail view. In a normal React app, you might transition from here to here immediately and then load asynchronously the data as it comes in. So that is what we're talking about when we talk about the better defaults. So for example, when we go from the main page and click, and we navigate immediately to the detail page, it's still loading the data. And within component did mount, that we load that data, and then finally it loads. So this so the spinner state is useless to us, right? This is useful to us. This is useful to us. That middle state is not useful to us. So under React Suspense, what that would do is actually send that fetch, and it fetches and renders in the background. And only when the fetch resolves, it navigates from the master page to the details page. So that's what we're talking about when we talk about React Suspense relationship to data fetching. But data fetching isn't just I guess, JSON data. We'll talk about the other forms of data fetching in the future. How you use data fetching is you're literally creating a fetcher that comes out of the simple cache provider or high-level API, and you pass in a strategy, which is just a function that returns a promise, and you read from the cache, giving it a key of a movie ID. And if that cache read is missed, this throws and the render is suspended here, and that data is going to be fetched, and then when that data is done fetching, it comes back here again, and it resumes rendering. So you can see that we're just rendering our data here, entirely within the render method, or I guess this is a functional React component, and there is no life cycles here to fetch data because we don't need that anymore. So that's data fetching, but data can take many forms. It can even take the form of images. So again, from the master view, clicking through and looking at the image source, and then loading the movie image that we might see here at the top. It might cause things to reflow around as the image comes in, and that might be a very nasty jump. And so wouldn't it be nice if under React Suspense we could just navigate to the detail page when the image is done loading. I have a very practical example of this, and here's an example of writing that image fetcher, which makes clever use of the image API. So I have a very clever example of why this might be important, and I call this the Hawaiian Missile Alert Software Edition. Imagine if you're programming a missile alert warning system, and there's an image that loads, and it makes you press the wrong button. That's a practical motivation for why you might want React Suspense for your images. So here, all right. So images, we got data. What else? We can do code splitting. So here we're code splitting because all the fetch functions are just functions that return a promise. So in the import command, the import keyword, I guess, import method is a promise as well. So you can code split just as easily as that, and so you don't render this. Well, so you don't fetch all this JavaScript until you actually need it, which is nice. So those are the three benefits that have been worked out: code splitting, image loading, CSS loading, which we kind of skipped over, and data fetching. And I consider all these subcategories of data fetching. And the goals that we're achieving are for pages or components to render when ready, and also to fetch to achieve fetches within the render as though they were synchronous, even though they're actually asynchronous, right? The strategy that makes asynchronous things synchronous is the cache reading and the suspending. All right, but we're not done. There's still spinners, and this is still a poop emoji, so we know we're not done with the cheat sheet. So here we talk about a new benefit, which is better defaults around race conditions. And a lot of times this happens, for example, when you go from the master page to the detail page, you might click a few different things, and what you end up navigating to is the thing that responds first, that responds last instead of the thing that you clicked on last. So those are the minor differences. So imagine you clicked on movie page 1, but it took a while to come back, and in the meantime you changed your mind and you wanted to go to movie page 2. Movie page 1 might override, and you might not know what you end up on. So this is an indeterminate end state. Whereas within the React Suspense world, the thing that you last clicked on, because it uses a cache, will be the thing that you actually see in the end. So that's the first sort of race condition that I want people to think about. So the fix for this race condition, it doesn't load until it the I'm not sure what I'm supposed to explain here. So when you change, so over here, for example, when we talk about changing between different, and let's say I change to Black Panther halfway through loading downsizing, I never see downsizing, I only see Black Panther, right? And that's because I'm already trying to display Black Panther as I load downsizing. But the completion of loading downsizing doesn't matter because I'm still trying to display Black Panther, and that's what's going on in that demo that I just did. And that's a very nice default because I never even have to think about how to solve the race condition. It's just done for me. The second kind of race condition I like to talk about is the loading of different components that don't know about each other. So over here, we're navigating from the master to the detail view. They're split into two components: movie details and movie reviews, and they each fetch data separately. But what if movie details takes much longer to fetch than movie reviews? Then you have the spinner here, and then movie reviews loads, and then movie details loads, and you get that little jump that you might see when that data loads. So that's not really nice. In React Suspense, obviously, again, you're only rendering when you're ready. So even though movie reviews loads first, it's still in the background, and you're still on the main page. And then only once you loaded all the data with the sibling, then you render the entire page. So that's the second kind of race condition that React Suspense solves. So and you notice this is how the code is in the demo. They are just siblings. They don't know about each other. There's no is loading Boolean here to control whether things are loaded or not. They just only render when the entire tree of this thing is ready to render, which is very nice. As a nice side effect, if you look at the test code for React Suspense, you can also see a debounce component. So what you do, because things render only when the siblings, all the siblings are done rendering, you can implement a delay component and put it next to your text entry, and that delay and this combined component, which we call debounce text, will only resolve once that delay component is done. So, and that delay component resets every single time there's a new text entry. So that's a very clever way of doing debounce without Lodash. All right, so two more benefits and uses, which is fixing race conditions, debouncing, and the goal of having no race conditions as your default. Obviously, like there might be other forms of race conditions, but those are the two main ones that people have identified. And then some portion of people who I present this to say, like, but what if I want spinners, right? I clicked on something, and if I see, so like if I if I click on the screen and nothing happens, I might think that my page is not responsive. Fortunately, we want to show we have a function to show spinners, right? So when I click here, I have a spinner here on the main page instead of the final destination page, which is the effect that we want to achieve over here. When I click index page, this is the first version where when I click on the next page, I want to move to the next page and show a spinner. No, you're not letting me do this thing, which would have been trivial in React, in normal React. Well, that's easy too if you just wrap a placeholder component, which we defined way back when, around the component that you want to show a spinner for. So instead of just doing the sibling method, which waits for all of them to resolve before displaying, you display movie details, which is the thing that you want to display, and then a placeholder component, which always resolves immediately. And inside it, you let it determine whether to show a spinner or a movie review component. This is what they call intentional states, and it lets you achieve a very fine-grained level control as to what you're showing. But really, it just resets the default, right? Like the default is to render entire trees when ready, whereas here you have to like kind of add extra code to make it behave like it used to before, and this is judged to be a poorer default than previous. And this is the other one that I started talking about, which is when I click on the index page and I'm loading stuff in the background, I want to have some sort of indication on my main page. So, so my user doesn't freak out that the click can go through. So to add this little spinner here, what you do is you add the loading component that we defined earlier as well. So all that is in the source code and was also talked about in Dan's demo. So that's the next benefit and goal, which is intentional states and precise controls. And here we get into like the fancier stuff of React Suspense. And what we're demoing here is faster UI with preloading. So React doesn't really have a good idiom for preloading. You can sort of do it with React Loadable, but now it's going to be fairly trivial within Async React and React Suspense. So basically, what you're doing is once you go from your main page to, for example, movie page 1, you land on movie page 1, and you know that the user might click next and go to movie page 2. Once you land, you can start loading the next thing, sort of preemptively, speculatively even. And not just loading, because we're not talking about async data fetching, we're also talking about async rendering. So so it really will be instant when they do move from the first page to the second page. And you can also see that in the waterfalls. This is taken from Ryan Florence's demonstration of reaction/fetcher, his fetcher API. Other preloading strategies can be also, they're all related to guessing, right? You want to guess, the file names of resources that you might want to load. Just load it in there. You don't have to display it. You can just load things within your render function. You can reload the n+1 query, which is the movie page 2 that we talked about earlier. So those are the two sort of quick wins for preloading. You do want to be careful with using this because obviously your users might be on mobile and they might not appreciate you burning their data for no reason. So that's preloading, and that's with the goal of speculative fetching. And speculative rendering, really. So the last goal is kind of the hardest to explain, and I'm going to skim over some of this because I think that I won't do as good a job as the React team of explaining this, but I do think it's important enough because there's a lot of this that doesn't need to be done within the core of React until you understand that React holds this as such a high priority that they had to rewrite the core of React. And this is the core of why async rendering is not actually such a defined split between time slicing and React Suspense. Like there is a relationship between them at its core, which is the interactivity element of it. So basically, what I'm terming this is that React should almost be renamed to interact, because the goal of staying interactive at all times is such a high priority, because React has a new job, which is to stay interactive at all times. For example, 60 frames per second, but that's just an element of why this is. Like why did React have to be rewritten to include the suspense feature? Why could it not have been done in user land? I think that's the main question that a lot of people have when it comes to examining the process that led up to this. So the focus here, I think, that the thing that really made sense to me is the new terminology the new terminology around what we've been trained to think. Like we've been trained, people who've been around with React for a while have been trained to think that committing to the DOM is expensive, whereas calculating differences in virtual DOM is cheap. And that's seems to be a misconception now, especially with async rendering. And now the focus is very much on where committing to the DOM is expensive, while reconciliation, which is the DOM diffing, essentially, that happens purely within JavaScript, is the expensive piece. I do think there's a certain element of like depends, like this stuff at the bottom is for much bigger apps, whereas this stuff at the top is for much smaller apps. So they're not 100% true in all cases. But that's why this terminology at the bottom is what we're really focusing on, which is committing to the DOM and reconciliation. Those are the two keywords that should be operative for all React users from now on. So this is not something that is so here's a chart that might be more demonstrative of what async versus sync is. So how React works today in synchronous mode is that we have an initial event, which is the green thing. Then we render, which takes a long time, right? Like this is the yellow bit, and that's why it's considered to be expensive. And then we commit to the DOM once we're done rendering, and then we have more browser events. Whereas in async mode, we're able to receive browser events all throughout the render because things are chopped up into tiny little segments. And only when the render is done do we commit to the DOM. And that's the pink bit over here. So you can check out these tweets for more detail. But that's kind of what the theory is. And it's not just theory. It actually is borne out when you try these things in the Chrome Dev Tools. So the source is here, and you can go check it out. But it's not just theory. Like this is actually why the interactivity will be guaranteed to be so much faster, because you have all these clear channels for interaction and receiving browser events and responding to them. So there's Dan Abramov uses a very convenient Git analogy. So I tried to take that and run with it. So if you think about if like you're a company that makes an emoji app with continuous deployment and no Git, which means that whatever you have in your development branch is continually just pushed to production. There's no Git branch. It's just continually pushed. So let's say you're in a happy state, and then there's a browser event that happens with the exclamation mark over here, and you're like, all right, I gotta go, do some work. But in that state of doing work, there's some stuff that needs to be done. So there's a deployment that's dropped here, and that's similar to a drop frame. And while you're working on stuff, you realize, oh, I need data, and I go fetch that data. In the meantime, stuff gets rendered in an incomplete state and work in progress state, and only when that data comes back, you return to a happy state, and that happy state is displayed to the end client, right? So this is continuous deployment, deploying every 16 milliseconds or whatever, and you've got 3 frames of 1 frame of dropped responsiveness because you've been processing and rendering, and 3 frames of displaying a half rendered state. So imagine if you had Git. What you would do is you would fork a branch for a work in progress while being able to deploy continuously at all times, even though you're working on stuff in the background. And only when you're done with your happy state do you do the rebase, which Danny Momov showed you. I don't have fancy animations, but essentially only once you're done rendering do you do the rebase of the history and catch up to where things are. So to the customer or to the end user, you always have a consistent happy state, and you have that happy new state at the end. So that's obviously very analogous to what we're talking about with React Suspense, which is you're happily rendering octopuses, you're fetching data, you're suspending and doing that data fetch and rendering work. And only once you're done once you're done with the data fetch and the rendering, then you display the new final end state. We should mention that they do take the Git analogy very seriously, right? Because these are all considered to be commits. So that's one form of Git analogy. And it is still in this is considered a work in progress branch. So that's a very interesting. I think this is a very apt way to think about it. Obviously, don't take this too literally. This model is probably wrong, but I do think that this is a good mental model of what's going on in the background, which you only probably need to know if you're working on tools or something very, very high performance. The other thing to note is that this could be also considered to be double buffering, which is a game programming concept. And also considered to be coroutines, which are basically, these are sort of this work that's being done in the background is kind of interleaved between the work that is essential for the render. So even though JavaScript is single-threaded, it's jumping back and forth between this work, and that's what React is doing for us, and that's the coroutine element of what React Suspense is. So I only talk about that because that's part of the conversation. So we start needing to keep a computer science glossary with all this stuff like coroutines, reconciliation, double buffering. We talked about that. The only reason, again, this matters is that React wants to be interactive AF. And we're still not done? Wow. And that's because this field is very much open to innovation. We may have a lot more creative suspense use cases, just apart from just image loading, like anything can be an image. We might have more different sorts of caches. For example, Rodrigo's Hitchcock library is a self-written cache that links directly into this dev tool that he has over here. And in general, we should see a lot of innovation over there. We are definitely going to see a lot of high-level API innovations because it's still not clear how we want to use this in sort of the most semantic way possible. So Dan has his .future file, which he doesn't show people, and Ryan Florence has his reaction/fetch file. What's the impact on existing React libraries? React Loadable is basically not needed anymore. What is the impact on React Router? Ryan Florence thinks that there should be a lot of new self-rolled React routers because people will want to customize the behavior a lot. There's going to be new dev tools, right? I showed off a new dev tool earlier in this presentation, which is this little Chrome extension thing, which is the lag radar. And there's going to be more. React dev tools may have to evolve to show things in the background, or it may not, and there may be something new that people can come up with. So those are all the question marks that are that people talk about. I did want to include the other stuff that I left out. It's hard to imagine I left anything out. I know this talk has been super long, but I did leave a bunch of links for the proposed benefits with regards to boilerplate reduction, streaming server-side rendering, algebraic effects, and these are the remaining sort of computer sciencey terms that are bandied about when people talk about React Suspense, which you may follow up on if you're interested, but you don't have to know. So here's the full final cheat sheet, and we finally rendered something where there's an octopus. I've added stars where I think there's opportunities for innovation, and warning signs for places which people are not really sure about. For example, there's an exploration concept in here, which is hard-coded within React, which I haven't talked about here at all. But it's going to be much more fleshed out when the API is finalized. I do think the most opportunity comes in the form of low-level APIs, because that's very core to how everyone else is going to be using React Suspense, as well as new libraries and dev tools. So yeah, that's it. And now that we've fully rendered our cheat sheet, we can resume our main presentation, right? And so imagine if we had React Suspense, we would just be interactive on these slides. And while that rendering stuff goes on in the background, we would be able to stay on the slide. And then only when it's done rendering and fetching that data, then we go onto the cheat sheet. So that was what I was trying to do with my React Suspense. I was doing Suspense with my own slides, essentially. I thought it was very clever. So what is, and so I want to end with a couple quotes. The first one is, what does React Suspense let you do without thinking? So we started this talk with, what does React let you do without thinking? And again, remember that civilization advances by extending number of important operations, which you can perform without thinking about them. So what React Suspense let you do is essentially have better defaults, right? I think that's the more human accessible way of doing things. Like we have made this judgment call that we want to be interactive and we want to show consistent states, and that is important enough to us to rewrite the core of React to do that. There are some trade-offs with regards to the APIs that we're going to be using, but we think that it's a better idea for the community as a whole. The other quote that I like is the pit of success quote, which is basically React is trying to guide people into winning practices and make it easy to do the right things by, for example, solving race conditions for us and making loading and eager loading and all that good stuff easier. Yada yada yada. Here's all the links and acknowledgments. This will probably be out of date by the time you see this. So the main thing to look at is go to this repo, fresh-async-react, and this I have kept in chronological order of all the things that are going on. So doing the work for you. And definitely check out some of the community code. It's really cool. And obviously, hat tip to all the people who've made this content possible so I could do this research. And that's it. I think, I don't know how long this talk was, but that was a long talk. And thank you for staying with me. All right, if I got anything wrong, which I'm sure I did, tweet me at Swix on Twitter, and I'll see you around. Bye.